So today we'll talk about magnetic field and magnetic force. So the magnetic field is generated generally by permanent magnet or by electromagnet. So the electromagnet basically, when you have a wire, in this wire there is a current circulating, the current will generate magnetic field. So today I will not talk about how this magnetic field is generated. I will just assume that there is a magnetic field, and if I put an object inside this magnetic field, how this object will react. Let's assume we have an electric field, and the electric field lines are vertical like that. And we put a charged particle inside this electric field region. The particle will feel an electrostatic force. However, if we change now this electric field and we replace it by a magnetic field, we write it B, like that, B vector, and we put a charged particle, what will happen? Well, nothing. There is no force on this particle. So what we need to get a magnetic force, we need the particle to move. So we need velocity vector. So if we have just a stationary charged particle inside the magnetic field, there is no force on this particle. When the particle starts to move, what is the force acting on the particle? F equal QV cross B. So we will be using the cross product between the velocity vector and the magnetic field. There is an important consequence here, is that the force is perpendicular to V and perpendicular to B. The force is perpendicular to both the velocity vector and the magnetic field. So basically the charge will move out of the plane. Alright, so what is direction of the force? Direction of the force is given by what we call right-hand rule. Okay, so here we have an image explaining a right-hand rule. So you orient your hand in the direction of the velocity, shown here, your finger pointing in the direction of V, and you turn them or you sweep them from V to B. So you turn your finger from V to B. The direction of your thumb gives you the direction of the cross product V cross B. Now, what is direction of the force? Well, if you know direction of V cross B, you will know the direction of the force. It will depend on the sign of the charge. If the charge is positive, the force is in the same direction of V cross B. If the charge is negative, well, the force in opposite direction. Now, what about the magnitude? Well, the magnitude is given by this formula, F equal, so we need absolute value of Q, the speed, the magnitude of the magnetic field, and the cross product will give me sine phi. What is the angle phi? Is the angle between V and B, shown here. So that's phi. What about the unit of B? Unit of the magnetic field? Well, we can get it from the same formula. The unit of B, that's Newton per Coulomb meter per second. That's what we call Tesla, and we write it just as T. I can write this equation differently. Newton per Coulomb per second. What is Coulomb per second? That's ampere times meter. So this shows me that there is a relationship between the magnetic field and the electric current. So let's have now our first checkpoint. So we have here different situation, and we want just to know what is direction of the magnetic force on the charged particle. So we will be using right hand rule. So you point your finger in the direction of V, you turn them or you sweep them from V to B, the direction of temp, it gives you the direction of V cross B. So you can see here that V cross B is like that. That's V cross B. Since I have a positive charge, the force also is in the same direction. So the force here is in plus Z direction. Let's do the same thing for a second situation. V cross B, you do hand rule, you will see that your temp is in direction of plus X direction. You need some practice to get it right. So we have a negative charge, so the force in opposite direction of V cross B. So it's in minus X direction. What about the last case? Well, V and B, they are in the same line, they are collinear, or even they are parallel to each other. So here the force is 0. This is the way how to solve this problem by right-hand rule. Is this the only way? No. We can use a vector formula here. So we have I cross J is equal to K. Okay. J cross K, I rotate like that, is equal to I. And K cross I is equal to J. So that's the way how to remember this formula. So with this, you can solve this problem. How we've been doing that? What is the direction of V cross B? So V cross B, V is in minus I direction, cross B, which is in minus J direction. I cross J, that's just K. And since I have positive charge, that's the direction of the force. Second situation, V cross B, so V is in minus J direction, and B is minus K direction. Yeah, G cross K, that's I, but I have a negative charge, so direction of the force is minus I. Okay, so that's another way how to get the direction of the force. Let's take now our first sample problem. So in this sample problem, we have a uniform magnetic field. The strength is given, 1.2 millitesla, is directed vertically upward in a laboratory chamber. So we have our lab room, and the magnetic field is in a vertical direction. So the vertical direction, I draw it like that. When you see a vector pointing like that, a dot, it means that the vector is coming toward you. That's basically the tip of an arrow. And we have a proton, so positive charge, positively charged proton, that has a kinetic energy, certain kinetic energy, 5.3 mega electron volt, and it's moving horizontally south to north. So it's moving in this direction from south to north. That's V. So the question is basically, what is the magnetic force acting on the proton? Well, let's see first the direction. V is in the north direction, like that. B is out of the page, so you do the cross product, right hand rule. It gives you the force pointing toward the east. Okay, so I get first the direction of the force. Now, what is the magnitude of the force? So F equal Q V B sine phi. The charge, that's the charge of the proton. The velocity, I don't know the velocity. B, I know it. And phi, what is phi? Well, B is vertical, V is horizontal. So there is an angle 90 degrees between them. Okay, so I don't know the velocity, but I know the kinetic energy. So what is the kinetic energy? That's half mv squared. So from this I can get the velocity, the speed, 2k over m. Now, how I calculate v? V is the square root of 2 times 5.3 mega. What is mega? 10 to the power 6 electron volt. So basically the kinetic energy, generally, it's an energy, so the unit, the standard unit is joule. So I need to convert electron volt into joule. I need to multiply it just by unit charge. Remember electron? That's 1.6 10 to the power minus 19 over the mass of the proton is given 1.67 10 to the power minus 27 kilograms, so that's fine. And this will give you 3.2 10 to the power 7 meter per second. Now, what is the force? So I plug V in this equation. So I get the force is equal to charge of proton 1.6 10 to the power minus 19, that's a unit charge. Elementary charge times V 3.2 10 to the power 7 times B 1.2 10 to the power minus 3. And this gives you 6.1 10 to the power minus 18 Newton. So that's how we solve this problem. The magnitude of the force is this one, and it's directed toward east. Thank you for watching. See you in my next video.